Okay, this is the final in the quadratic problem solving sequence of videos I'm going to do, and this is probably the most complicated. So what I'm going to do is I've got to find where the function is less than 0. If I had a graph, it would be easy, and in fact I'm going to show you the solutions on the graph afterwards just to check my results. What I'm going to do first of all is I'm just going to look at fx, and I'm going to make it actually equal to 0. Now I'm also going to rewrite fx by trying to factorize. So if I factorize the top, I get this, and then when I factorize the bottom, the denominator, I get minus 5, sorry, that should be a plus 5, and x minus 3. Okay, now I'm going to make it equal to 0, and we're going to use this less than right at the very end. Now clearly we should know that x cannot be 5 and x cannot be 3. Make that negative 5 rather, because we can't have a 0 on the denominator. These two values are going to be important because they're going to be part of my critical values. Then on the top, x equals 4 and x equals 1. Now this is the bit that students always find a bit difficult, is we're going to put those 4 values onto a sign diagram. So we have a nice long sign diagram, one big straight line, and I'm going to add 4 here, 4, 3, and they don't, this is just a rough diagram, 1 and minus 5. So let's put those in. Minus 5, 1, 3 and 4. And I'm going to check these 5 regions where I've drawn a dot. So I'm going to check when x equals 5. And I'm going to put that into my function at the beginning here and see if it's less than or greater than 0. Now you're going to take a calculator and put all that, put 5 into that function, and you will find that it comes out as being positive. Now if it comes out as being positive, your answer here is positive. We actually want fx to be smaller than 0, so we don't want that region. So anything greater than 4 we don't want. This is a complicated one, but if you choose x to be equal to say 3.5 and you check it, it comes out as being negative. And you can do that yourselves, but it comes out as being negative. So we want that to be, that's what we want. We want something less than 0. I'm going to check x equals 2. Now when I checked out x equals 2, it came out as being a positive value. And we don't want positive values because we only want fx is smaller than 0. Here, a nice easy one to choose is x equals 0. And it gives me a negative value, and I want that negative value. And here let's just choose something like minus 6, and it gives me a positive value, and I don't want positive values, so I don't want this. So I want x to be 4, I want x to be smaller than 4 and greater than 3, or I want x to be greater than minus 5 and smaller than 1, and nothing else will work. Now that's how you do it with a sign diagram. I haven't had to use a graph at all. I might have had to use a calculator, but if I go forward now, let's just take our answer and copy our answer so we can put it onto our graph. If we go onto the graph here, so this is actually the function all graphed, we can see that when we're above 4 here, let's put the highlight on, if we're above 4 here, we're above the line, and we want to be below the line. Between 4 and 3, that's fine. And then this value here is 1, and we're again below the line from 1 up to minus 5. That's a 6 there if I zoom in. And then here, that doesn't work. So we can see clearly that our sign diagram has helped us to get the parts on the graph that are less than 0. This is a pretty tough question. Whenever you have questions like this, always remember that denominator part plays a part in solving these.